All right, let's begin. It will, as I said, for all the ones that are present here, I think that this workshop will be a little bit longer than the hour that was scheduled. I usually speak quite fast, but please do stop me if you have any questions. Let's try to no one, Valen, actually. I'm glad that you're here, the ceiling god. So please stop me if you have any questions. I will go through a lot of theory. I will show you certain parts of AWS from the practical standpoint as well, how to do things. But again, any questions or anything, feel free to stop me. I prefer to take my time during these workshops so everyone gets at least, and myself mostly, a sense of accomplishment. So just let me know. Let's begin. Again, this will be the AWS fundamentals, although we are going to tackle pretty much the certification for so it's the CSAA, which is the architecture associate certification for AWS. We're going to go a little bit further down. Let's go. So who am I? Let's begin with that. For those that do not know me, I'm Jonathan Tissot. I'm a senior site reliability engineer. I have certifications on AWS, Azure, GCP, Terraform, Kubernetes, and a few others. I achieved the professional ones for the 3 major cloud providers. I moved from Argentina to Uruguay. There is a picture of my 3 dogs. I have 2 chow-chows and 1 Yorkshire. Let's continue. I'm 35 years old. So this is what we are going to discuss during this workshop, which is pretty much what to expect from the exam. And we are going to discuss 4 domains. These domains are related to the domains in the exam, and at the right is the percentage of how important they are for the exam. We are going to discuss a little bit about the exam structure and whatnot. So domain 1 will be everything related to security. Domain 2 will be everything related to resiliency. Domain 3 is high performing architectures, and domain 4 will be regarding to cost. Please stop me if you are okay, if you're not okay. Okay, so let's go for the exam architecture. There are several certifications from AWS, being the first one, the Cloud Practitioner Foundational. That one pretty much asks you to know which services you have available within AWS, what are they used for and whatnot. Then we have the Solutions Architect Associate, which is the one that we are going to discuss during this workshop, which is pretty much a general overview about the architectural standpoint that you should have whenever you're working with AWS. The professional one is a little bit, obviously, it requires more knowledge. Then we have the DevOps, or Development and Operations, which is at the beginning, those are split. And afterwards, you have the professional, which is a single one. For any of these certifications, you don't need to tackle the associate one. You can just jump straight to the professional if you feel comfortable with it. This happens. There are many people that has worked with AWS for several years, and they might want to, I don't want to waste my time taking this one, I will take the other. And other people like to grind certifications, so they go for this one, and then afterwards they go for this one. All right, and then we have the specialties, which obviously are independent between each other and are related to certain specific topics like database security, SAP, data analytics, networking, and whatnot. But again, we are going to go for this one in this workshop. All right, the hours, I don't need not even 2 hours, I need a few days. So what the CSAA, or AWS Certified Solutions Architect Associate, validates basically the candidate's ability to use the AWS technologies. And following the part of the well-architected framework, I have done a well-architected framework workshop in the past. I did it for Measure Key when we were in Erdegarla, so I think it's in YouTube if you want to check what that is about. If not, there is a lot of other documents and a lot of other people that might give that in a better way, maybe, or maybe not. Maybe I'm really good. Mostly verifies if the candidate is able to, point 1, design solutions that goes with AWS services to meet the business requirements, right? These are architectures that are secure, resilient, high performing, and cost optimized. These are pretty much the 4 domains that we discussed in the index, right? And be able to review existing solutions and determine improvements, which means that aside from knowing the solutions that you can build with AWS, you need to take into consideration all those 4 pillars. Plus, you need to be able to, if someone gives you a current architecture, be able to spot, all right, we could improve this. This certification needs to be recertified every 3 years. Obviously, you have a discount for that. First time is $150, if I recall correctly, and afterwards, I don't recall what's the price. I need to recertify mine actually. So what are the exam mechanics? So the questions that you're going to find are either multiple choice, which is pick one from many, or multiple response, pick several. I have a few really basic examples, not related to AWS whatsoever, but serves the purpose of showing what's what. 65 questions, 15 of those are not evaluated. Those are used for the newer versions of the exam. So most probably you're going to have 15 questions that are pretty much unique, and it's to test for the next revision of the exam that will be included, and then it will be evaluated. But at this time, only 50 of those 65 questions are valid, although you cannot discern which one is what. So you pretty much need to aim for the 65. There is no penalty for wrong answers. So this means always answer something. And if you have any doubt, you can mark the answers and then come back. If you have done any of the exams for any platform, at any point in time, you had this since several years already. The minimum score to pass is 720 over 1000, and you have 130 minutes to complete the exam. Although if English is not your main language, or there are other things that you can say, you can get a few more minutes to this, like 20 or 30 minutes more. Although the first time that I went for this exam, it took me 20 minutes. So just for you, because the questions are really straightforward, really short. The professional one, they gave you lengthy questions with a lot of details that you need to read. For the associate is way simpler. We are going to check a few of the questions that they have in the exam. Let's move forward. So multiple choice example, this is what I said. One of many, right? You need to pick one of the answers that is that is according to the question, obviously. Multiple response, where you need to pick more than one, right? They will always tell you how many you need to pick. It's not like up to you. They will say, bro, you need to pick 2, 3, X. And this is an important one that you're going to encounter, which is multiple choice order, which is every answer has an order to do things, and you need to find which is the right order. For this, you pretty much need to know the process on how to implement something. Let's go forward. These are the general strategies for the exam. I'm going to go for AWS in just a bit, all right? It will be the first domain. First, I'm going just over the exam. That's it. Any questions so far? Anything? No? Everyone is alive still?
And breathing.
That's good, Mark. All right. Keep on doing that. That's healthy. Fully read both the question and the answers at least once, all right? You are going to have a question, read it totally, all right? Don't try to take conclusions at the moment, just read it, pay attention, and then you can do it again, but maybe taking away or identifying the features within the question, as said in the second point, right? But first, read the entirely. Identify qualifying clauses like cost efficient, highly available, fault tolerant, so on and so forth. So whenever you are talking about highly available, you need to know that at least one of 2 or more of something you basically need. Ergo, you can remove certain answers as valid, right? Eliminate those questions that seem so obvious that it's not the way to go. For example, if they ask you for an EC2 instance and one answer is, we are going to work with S3, it's like, bro, we are asking an EC2 instance. So that's it. Let's go. Let's begin. Domain 1, security part, all right? So this domain tackles mainly 3 points, which is the secure access to AWS resources, secure application tiers, and choosing the proper security options for the data. The data needs to be secure, not only at rest, but in transit as well. So first and foremost, let's discuss a little bit about the shared responsibility model. This is something that is pretty much widely used, not only for AWS, but for several other cloud vendors. which is there is a part that is entirely AWS or your cloud vendor or a third party is entirely responsible of, and then there is one part that you are responsible of. Now, this comes with the definition. So this is a simple schema for the shared responsibility model where AWS tackles the software, computer, storage, database, and networking from the low tier, and then whatever you put on top of it, like an operating system on a virtual machine, or the platform that you're running on that virtual machine, or any data that you have in that virtual machine, is your responsibility. So you need to keep it safe. AWS will take care of keeping safe anything that your application relies onto, but your application per se and whatever components makes your application, you need to be sure that you have the proper security standpoint to actually safeguard that data and your application altogether, right? So for that, I will just pick, hold me a second, because I have a better diagram that I made for the shared responsibility model, because this actually is a matrix in the sense that the shared responsibility model is not the same. It's not the same for every single one, right? This is when we are running on premise. So when you have your own data center, you have worked with this in the past, right? Everything is your responsibility, from the physical networking to the storage to the physical service utilization, OS, so on and so forth. Now, once you go to the cloud, right? In the cloud, you can opt in for several services and several type of services. Between those type of services, let's discuss about these three, which are the main one. There are many more, but let's go for these three, which is infrastructure as a service, platform as a service, and software as a service. So the infrastructure as a service part is whenever you are spinning up a virtual machine in AWS, right? That's infrastructure as a service. You are getting infrastructure from your cloud provider as a service. In that case, right, the virtualization platform, the physical servers behind the virtualization platform, the storage, and the physical networking, everything here is related to the provider's responsibility. In our case, will be AWS. Meanwhile, the OS that we deploy, which means that not only the OS, but the security patches and whatnot, middleware, runtime data, applications, and credentials, this is all on our side. When you go for a platform as a service, this goes a little bit further. For example, this will be RDS. RDS is a relational database system. We are going to check that in the domain 3 or 4 or 2 or 3, I don't recall, which is a database that AWS provides. When you pick a database, you just pick which engine you're going to use, PostgreSQL, all right? So everything that you pick from there will be handled by AWS. AWS will say, all right, I will handle the OS. You don't have access to the OS. You don't have access to pretty much anything except the database per se. So you have access to this, which means that you need to take care of this, right? This is your responsibility. And software as a service, like your Gmail account or Office 365 or anything like that, well, pretty much Microsoft or AWS. I mean, AWS will be in the sense that if you are using any of the software as a service that AWS provides, they will take care of everything here, right? For your Gmail account, you don't know where that is running, in which servers, what's the availability, you don't know load balancers, you don't know anything about the architecture, right? So what you know about your Gmail is your user and password, which is your responsibility, all right? If you put password 123 as a password, then Google will not be able to do much, right? They will maybe help you to recover it, but again, so it will be your responsibility. Google will not force you to do anything for that. All right. So keep this in mind. There is a part that is AWS is responsible for, and there is a part that you are going to be responsible for according to the different types that we reviewed just a minute ago. Remember which part is part of AWS and which part is not, all right? Some of the questions might be related to that. Now let's discuss IAM. IAM is the identity and access management part. So I will try to make this as entertaining as possible. I will open up an AWS console and I will follow up certain slides with you guys, so you can at least see, if you haven't, see what the AWS console looks like, and maybe that will be able to help you out understanding a little bit more about what we can do. So let's go for the slide first, then I will go to the console and check it out with you, all right? So what does IAM does? Well, centrally manage user groups, permissions, roles, whatever in AWS. This is only for AWS. With AWS IAM, you can create user groups, roles, and policies, and define permissions to control which AWS resources a user or process this is super important, not only for users, but a process. We are going to see roles for that, could access, and at which level. And at which level means which kind of permissions you have regarding AWS resources. IAM can easily be integrated with Microsoft Active Directory. This is not something that we are going to check, because for that I will need to spin up a Microsoft Active Directory, and that will take me like, configuring this will be a 45-minute task. I will not do that. And AWS Directory Services using ING Federation with SAML. So, right. So for the console, for those that do not know how to access the AWS console, all right, that's good. So I'm going to use one of the accounts. So, yeah, generic user 1. All right, that's good. So this is the console. You log in the console via 2 ways, either using a root user and password, which is the root user account for that account, or you use a user that you created in IAM, all right? So as we said, IAM, which handles the user groups, policies and whatnot, is something that you can just look up here in the search. You have by default the favorite icon here, and here it will allow you, aside from saying, bro, you have to do a lot of things. This is super important. You can create here users, groups, roles, and policies. So how these are interrelated? Whenever you create a policy, you can create policies that allows you certain type of permissions into an AWS service. Remember, this is totally related to AWS, not related with anything else. So let's say that we want to use S3, right? S3 is the object storage. We are going to review it in a bit. And here we can pick which is the access level, right? You can do this via the visual part. You can put a JSON file for the policies and permissions and whatnot, and you say, all right, I want read-only list and read, because the list I need that, which will basically be a custom read-only, policy, all right? Oh yeah, sorry, that was not it. Here you can define certain resources and whatnot, request conditions if you need to have any conditions. Yep. There you go. Now here you can add certain tags in case that you want, like managed by. If this was created by Terraform, you will have it something like that. Now here I will put that. There you go. And I will create a policy. Now, this policy, what this policy does is allows whomever has that policy read-only access to S3. That's one example, right? Now I have a user, I have my generic user 1 here, and within the permission policies, I have several. Obviously, I have the administrator access. If I want, I can add permissions, right? And I can even create a group for this. Touch policies directly. There you go. Here, I will find my policy. I will click on next, and it will add the permissions to my user, right? So now my user, generic user 1, has the policy for the read-only on S3. That's one way of doing it, right? What you can do actually is creating a user group, right? And within this group, you can go to permissions and attach the permissions here. And then you add basically users to this user group, and with whatever user is here, they will have access to that policy, ergo they will have those permissions. Now that's one way of doing it. I'm trying to go this super fast, sorry, because if not, it will end up really late for you. And then you have the roles. So what is a role? A role is pretty much whenever you want to change your hat. This has been seen in previous implementations in infrastructure. Whenever you have like your user and user_admin, that's an old way of doing that you were using the _admin to do administrative tasks. In this case, what you can do is just create a role, right? Allow a user to be able to switch to that role to execute certain things. So instead of having the permissions attached to a user, you will have those permissions attached to a role. Now, the other thing that a role can do is that it can not only be assumed by a user, but it can be assumed by, for example, an EC2 instance. So let's say that you want to grant an EC2 instance. An EC2 instance in AWS is basically a virtual machine. You want to grant that virtual machine access to certain AWS resources. Maybe make that EC2 instance able to create an S3, an object storage, or create another EC2 instance, or do some other task. So if you want to do that, the first thing that might come to your mind will be, all right, I will create a user that will be called automation user with a non-expiration data for the keys, and I will just pass those credentials into the EC2 instance. Now, the problem with that is anyone that gets those credentials, they will be able to access your AWS account as well, which is really poor practice, and it will be a huge security risk since we are discussing security. Now, what you're going to do is, instead of doing that, you're going to create a role, all right? And when you're creating the role, you can say, all right, which of the AWS services will be assuming me, right? So you can say, hey, EC2, which is the virtual machines, and here it explains, allow EC2 instances to call AWS services on your behalf. And so this won't be, no one will be able to stole this from you. Actually, it creates short-lived credentials. So in a really short span of time, they might be able, but that will be like too much. But this is the most secure way of tackling as an AWS service being able to do a task against AWS. Questions? Anything? Everyone's alive? No seppukus, no harakiris? Good. Everyone died. That's good, Valen. Glad to hear. Or glad to read it, actually. Let's go for the following. So that's IAM. So IAM users, which are users within the accounts, roles, we went through that. Federation are users with identities within Active Directory. Basically, what we do is we have the ability to, using Federation, being able to integrate AWS IAM with an Active Directory, as I explained before. And Web Identity Federation, which is a different thing, allows you to have users that have accounts in, for example, Amazon.com, Google, and whatnot, being able to perform certain type of actions with AWS. That's mostly used, or that the most common implementation for that is whenever you're using Cognito and whatnot, which is something that we are not going to discuss. Now, let's go for the funny part, which is mostly related to infra. Computer network architecture, right? The principal component of the network part of this is the VPC, or Virtual Private Cloud. For those that do not know, the Virtual Private Cloud basically is, as it says, your private cloud. Your first definition, the biggest definition that you can have regarding the infrastructure part. So here, what we are going to do is going to VPC, which is Virtual Private Cloud. Let me know if I'm going too fast or maybe I'm going too slow. All right. I'm not sure if I have room for improvement. If you tell me that I'm going too slow, or maybe I'm doing it just right. So when you go to your VPCs, to VPC part, you can go to your VPCs. You can click on the create VPC. I usually don't do this manually. I do this using Terraform, but it's good to know where to go nevertheless. So here you can pick, this is a really cool wizard about what to do. So if you go for the VPC only, you will need to create everything by everything yourself. You go for VPC and more, here it tells you, all right, what do you want to do? Oh my gosh, this creates everything for me, subnets and whatnot. And there is a route table for public and route table for private. We are going to check this in a bit. So this basically does everything for you. Whenever you do it manually, you can say, hey, how many availability zones you want, number of public subnets or private subnets, customize the subnet area blocks and whatnot. So you just put a few details here. Obviously, for this, you will need to have a basic knowledge regarding subnetting, which if you do not know, let me know via Slack, and I will try to explain you. It has a lot of binary in it. So what are the VPC endpoints? That we can discuss now that I think of, I didn't put anything on the slides regarding the VPC endpoints, so I can explain that. DNS hostname and DNS resolution, and then you can just hit create VPC, which is something that I'm not going to do. What I'm going to do is just create mine, because I can explain you what you need to do to actually have a fully functioning VPC. Because if you do the wizard part, you most probably won't know. So this will be a test VPC. Let's call it workshop VPC because we are so crazy today. Here, this is isolated. So even if I have another VPC, so this is important, a few things here that you need to have in consideration. If you go to VPCs, right, and I have two VPCs, and as you can see, the VPC CIDR block for this, right, is the same. So Because why? Because these are fully isolated environments. They don't see between each other, even though I see them in the console, right? Right now, they don't have by default a connectivity between them. But John, can you connect these VPCs together? Yes, you can. You can create a VPC peering. You can even create a site-to-site VPN if you want to. Easier will be to create a VPC peering, which is the default, or you can create a transit gateway. That's something that we are going to check in the upcoming slides. Now, as you can see, I can use the same CIDR block. Obviously, an issue will be if I need to have a connectivity between these two. If I need to create a VPC peering between these two, I won't be able to because I have an overlapping CIDR. So even though these are isolated, whenever I don't want them to be isolated, I will have an issue. Keep attention to the CIDR blocks that you're using or your company is using. Remember always to try to just create a different one for each VPC. If at some point in time in the future, you need to interconnect those VPCs, you won't have the issue of needing to change this IP, because that means a huge change for every single component that you have in there. So it will be better if you design from scratch properly. All right, so let's create this. I'm going to pick the same CIDR block. All right, here you can put the name with the workshop VPC. You can put any other details like department, and let's put it MKT, create VPC. What this will do, it will just create a VPC. That's it. It will create me a VPC with this IPv4 CIDR block, right? I put a really small one. Not an issue. So that's it. I don't have subnets. I have only one route table, which is the default route table, and I don't have anything else, right? So let's go for the slides, and let's go and see what's going on, what we can do with that afterwards. All right. To design network architecture in AWS, you need to keep in mind, obviously, the security, routing, network isolation, administration, and bastion host. We are going to check all of that in just a bit. Here I have the schema of what we are going to do in AWS, but let's go first for this one. So VPC connectivity options. Internet gateway, important, all right, for certification. Internet gateway allows you to get to the internet. You don't have an internet gateway, you won't be able to go to the internet to the internet at all. NAT gateway is what NATs the traffic. NAT stands for network address translation. So it translates your private IP to a public IP, and that NAT gateway will go through the internet gateway. All right. Then you have the VPC or virtual private gateway, which is how you configure a site-to-site VPN. I won't be able to do that in this workshop at least, but if you have a question regarding this, just let me know. I've done plenty. Direct Connect, this is a specific service of AWS that goes through a third-party vendor like Verizon, or there are many. So it's not something that AWS will provide to you. You need to have a third party that will basically do the physical connectivity between your data center, the third-party data center, and the third-party data center has connectivity to AWS. So you go directly to AWS. Now, remember that this could be something that might get asked in the exam, but remember that this takes time, all right? Anything that involves a third party will take time. So if something is urgent and they say, bro, we need more speed to connect to AWS by tomorrow, okay, bro, you won't be able to deploy AWS Direct Connect, so that will be an incorrect answer. It will be a correct answer in the sense that you might get a faster connection, but you won't be able to do it in one day. Another thing that you need to keep in mind regarding Direct Connect is that it's not encrypted. By default, it's not encrypted. So if you want to have your traffic encrypted within this, you need to create a site-to-site VPN across the Direct Connect. All right, just remember that. You need to create a site-to-site, an IPsec VPN tunnel. VPC peering, I mentioned it while we were talking about the VPCs. It's a way of connecting two VPCs together. Remember, this is non-transitive. So if I have a VPC peering between two VPCs and I have another VPC peering against a third VPC between the second VPC, it will not be transitive. I need a connection between A and C to have that connectivity on. All right, there is no transitivity. Now, if you want to have a spoke model, you will go with a transit gateway, which is another service of AWS that we can check. Yeah, that's it. So, questions? Anything? So good so far? Are you excited? You dead? That's good. Okay. Let me know in the chat. I'm reading the chat. You don't need to answer me verbally. All right. Subnet configuration. Subnet configuration. For the subnet configuration, we have two types of subnet, sorry, the private subnet and the public subnet. The private subnet is obviously the one that is internally, and no one has access to this private subnet unless you are internally talking to it. And then we have a public subnet. Now, the differences that there are between a public subnet is pretty much the route table. So the route tables for a public subnet will always have this entry. This entry is by default, all right? This is the VPC CIDR block, and the next hop is local, just for AWS to know that you basically need, you are within the same VPC in this subnet and this subnet. But the second entry is not by default. This is something that you need to create, which is the 0.0.0.0/0, which is everything or everywhere, go through the internet gateway. This is a route table that will be attached to a public subnet. In a private subnet, in the other hand, you're going to have to, whenever you want to go to everywhere, go to the NAT. Okay. Now, how the route table applies the routes. It's not in order, because most probably you have worked with a firewall in the past. It's not in order. It will be according to the segment. So the smallest segment will take precedence. If you have a 26, this will take precedence over the /0. If you have a 32, it will take precedence over a 16, over a 24, and whatnot. Okay. So if you have a resource like for example, this EC2 instance deployed in a private subnet, whenever you want to go to an external resource, let's say Google, you're going to go through the NAT gateway. The NAT gateway will, as it is living in the public subnet, it will go through the internet gateway. And from there, you're going to get to your external resource. Okay. That's good. If you want, I'm not sure if you prefer this, I can just do the VPC configuration of everything here at this moment before moving forward, or we can move forward with the presentation. We have just, let's call it 72 slides. So yes, it becomes funnier after a while. Let's go. I will continue, because if not, I will never finish. And then we will be able to do we will do the AWS part and deploy any EC2 instance and show you that and whatnot. So the difference between private and public subnet, I explained this a little bit. So routing table does not go to an internet gateway. It goes to an NAT gateway or to another EC2 instance. So you have many options actually. Anything within it will not be accessible from the internet. So I have no way whatsoever to connect to that instance unless I put something in the public subnet that will have the public IP. But you won't be able to go directly to a private subnet. To enable outbound connectivity, it should use either a NAT gateway. NAT gateway is by default the best option because it's a managed service from AWS. Something that we will see over and over again across this presentation is that any service that it is related to AWS will be preferred. A proxy or a bastion host, right? The subnet, public subnet, I forgot to change this because I did this in Spanish the last time. Public subnets, basically to handle outbound and inbound connections to or from internet, it just need a routing table pointing to the internet gateway. I need to modify that. I will do so before sharing this presentation. Security group versus the network ACLs. Now, when it comes to security, you have several ways of securing your infrastructure. Aside from the routing that you can, with the routing, you can prevent certain accesses or not being able to return somewhere. But from the security standpoint specifically, you have two ways of doing this, according to AWS. You have the security groups and network ACLs. Obviously, you have an internal firewall in your Linux instance. You have your IP tables. You have many other options. But again, this is AWS. They will not ask you about that. In GCP, on the other hand, they ask you about that. So in AWS, thankfully, they are not. So security groups versus network ACLs. Key differences. Security groups are stateful. Networks control list are stateless. The rules in security groups, you can allow only, meaning that you cannot deny. Deny is by default. So whatever you are adding there, it's allowed. And here in the networks control list, it is allow and deny. You need to specify both. All right. You can specify both. Now, what is stateful and stateless here? Because you might have seen this whenever you're discussing about an application, if it is stateless or Kubernetes or whatnot. So stateful means that whenever a connectivity, so you're allowing the inbound in the security group. Whenever you're allowing the inbound, for example, yeah, I will accept connections at the port 80 or port 443. The return traffic will be by default allowed. That's the stateful part. In the network access control list, in the other hand, you do not have that. So if you allow the port 80 and 443, you need to allow as well the ephemeral ports, which are the ports about 32,000 something, because if not, your application will not be able to talk back to whomever was doing a request to your application. Okay, that's the difference between a stateful and stateless. And the last part, and not least, this is to which is applied. Oh, I forgot to translate a lot of things. So this is applied to the ENIs, which is pretty much the network interfaces of your EC2 instances or RDS, or there are many services that uses the elastic network interfaces, even load balancers. But this is applied to the entire subnet, all right? Which means that if you have a super restrictive NACL, right? Let's say that you only allow port 80. If you allow here in the security group the port 443 as well, the NACL will prevent that from happening, all right? And this applies to the entire subnet. You cannot pick which resources you want to apply that for. In the security group, in the other hand, you can be a little more granular instead of coarse-grained, and you can actually do this on a per instance basis or per application basis. I leave there a few complementary docs. Now let's talk a little bit about security data in transit. So you need to take care of the security, as I said, in two ways of the data in transit, which is the data that is traveling, right? And the data at rest, which is whenever the data is saved, all right? In the data in transit, obviously, you can transfer the data by using SSL. So you can create a certificate. Most probably you have used that. The service to create a certificate, if you want to use the AWS managed service, is ACM, which is Amazon Certificate Manager. IPsec VPN, right? IPsec over AWS Direct Connect. I explained this already. Import, export, and Snowball. Import, export, Snowball. These are three services from AWS. Import, export allows you to send. You can send a device to AWS, so they can load it up, and that should be encrypted. And they have a few regulations. A Snowball is you ask for that device to AWS. AWS will send you a Snowball, and you are going to load your data there, and then you are going to send them through DHL to AWS. And then there is another one that is a track. Literally, they are sending you like a track if you want to send. I'm not sure how many petabytes of data. Data sent to AWS APIs is always encrypted. All right, all APIs of AWS, they are using HTTP SSL. Now, data at rest. We have many things to discuss here, but let's go swiftly. Just for you to know that rest, remember, is when the data is saved. Now, the thing is that the data in S3 is private by default. So whenever you are saving data in S3, I will discuss in a bit what is S3 in case that you do not know, and I will show you what it actually is in a bit. It's object storage, right? So whenever you are saving a blob there, let's say that you are saving a file for a time being, then I will explain what's the difference. It will be by default private. No one will be able to access it, all right? You need to specifically allow the public access. Now, for you to access to the S3, it requires HTTPS. You can define that. You have an access audit, or you can audit the access to any single object and support access control list and policies, which means that you can fine-grain the permissions regarding up to every single object, right? You can do it on prefixes, on buckets. This is called prefixes, not directory, because it's object storage, but just for you to have an analogy, it's pretty much like a directory or folder, right? Encryption options, you have two kinds. You have the server side and the client side. The server side, the S3 managed keys, which is the default. This is the default SSE S3. Then you can create your own keys on KMS. KMS is Key Management System from AWS, where you can create your own keys and implement those. And then you have the customer provider keys. Whenever you want to provide your own keys, let's say that you have an HSM and you create a key and you want to implement that key, then you can use this kind of encryption. So AWS won't have access to your data in case that you are using a Tin Hat. Encryption options from the client side, you have the master encryption keys administered by KMS, or you have the master encryption keys administered by the customer, same thing as from the server side. All right, so those are the encryption methods. Now there are many services that are integrated with KMS. A list of those is EBS. EBS is Elastic Block Storage, which is pretty much the volumes for the instances or the block devices. S3, object storage, we mentioned that just a moment ago. RDS, Relational Database System. Redshift, which is the data warehouse. Elastic Transcoder, they will never ask you this, and WorkMail either. EMR, which is Elastic MapReduce, maybe at a professional level, that's not something that we are going to discuss. Nevertheless, just need to know that these services are integrated with KMS. Complementary docs, domain one axioms. So at the end of every domain, I added a few axioms like, bro, this will be whenever you are getting a question from the exam, if any of these happens, please, this is the right answer. Remember always lock the root user, which is the main user of the account, right? That user shouldn't be used. You need to have an administrative user, but never use the root user because the root user has many permissions. It's pretty much like what you do with the Linux instance, right? You can only load traffic with security groups, with network ACLs. You can also deny, remember this, if they are asking, hey, can you deny, we can deny the traffic from the security groups. No, you cannot, you can only allow. Always go for IAM roles before access keys. I explained this at the beginning because these are short-lived versus a long-lived credential. Let's go for the domain 2. Domain 2 is resiliency. So this is a multi-tier architecture. What is high availability, fault tolerance? What is decoupling? What is a resilient storage? And what is how are we going to pick, or what should we take into consideration to pick the right storage for every single application? Snow Mobile. Thank you very much, Willem. Love you, mate. It's really fun. That's the track that we mentioned. We were talking about Snowball. So what is decoupling? Decoupling basically is, instead of making every single component of your application reliant one on another, what you're going to do is add something in between, right? There are certain applications that could do this, right? There are many applications that you cannot do this. It's not like, oh, this is a magic formula. No, because there are certain applications that requires the process to be done immediately, like whenever you're working with credit cards or debit cards or banks, that whenever you're doing a transaction, that transaction should be reflected almost instantly, if not instantly. Otherwise, you could actually get into a really high debt with the bank, and the bank doesn't want that, because then they will need to explain why you were able to do that. But anyhow, for other applications, what you are going to do basically is putting something in between the components that will help you in the case that any of the components goes down. One of the most common examples is whenever you're working with a message queue. You have many. You have RabbitMQ, for example, FTMQ. You can even use Kafka for that. Kafka sometimes is an overkill. You can use any others. You can even use a Redis in-memory database. You can use whatever you want, right? So the idea is just to have the idea in a more graphic way is put something in between that if any of the things that you have of the main components, they will be able to go down without impacting your entire application. Now, aside from that, decoupling has another benefit, which is that it will allow you to scale. Obviously, again, this depends on the application infrastructure. It's not like, yeah, with this, everything will work fantastically. It's not like that. So what this helps is that if you have a message queue, right, and you have one producer or many producers, then you can have one consumer, or you can increase this, which is horizontal scaling or scaling out. We are going to check that. I have a slide for that. So you can have 3, you can have 4, you can have 5, 6, whatever amount of consumers that you want, that they will take that from the message queue. So this will allow you to scale accordingly, right? Another way of doing this is obviously you can put a load balancer, for example, in the middle of it. Now the thing is that the load balancers act centrally different of what a message queue does, right? But it's another way of decoupling. Load balancer is as well decoupling, right? So let's discuss 2 topics: high availability, all right, and fault tolerance. So let me explain what high availability is. According to AWS, there are many definitions. According to AWS, highly available is whenever your application is able to go through an event that could impact its availability without impacting its availability, but impacting their performance. Okay, that's highly available. Let's say that you have an application that runs in 2 servers, right? And your application supports 100 users with those 2 servers. If one of the servers goes down, you're going to serve 100 customers in only one server, which means that your application will keep on working, but it will work maybe at half the speed. If you are impacting the performance and not impacting the availability, then that's highly available. For AWS, remember that. Fault tolerance, in the other hand, is whenever you have an issue and your application keeps on working as if nothing happened. So let's say that you have the same application that you had before, that you were serving 100 users without an issue in 2 servers, and instead of having 2 servers, you have 4. If 2 servers goes down, your application is fault tolerant because with 2 servers, you are not impacting the performance of it. All right. Cheers, guys, for whomever said that they were leaving, Mark and Alan. So that's the difference, right? Tightly coupled means that if you do something that attach the servers to the backends directly, like what we are doing here, if one of the backend servers goes down, the entire application will go down because one of the servers of the 3 servers that you have here went down. Now, obviously, if you add a load balancer in between, what the load balancer does is creates a health check against the servers. And if one server goes down, it stops serving requests to this server. So for these 3 web servers, the backend is still okay, although it's not. So you can work on it, but the application will keep on working, will keep, functioning. Oh my gosh, EC2 instance store. Instance store is a specific type of disk within EC2 that are basically ephemeral volumes. Ephemeral volumes means that do not put data that needs to be persistent there. It's not available for every single instance, only for certain, right? There is a fixed capacity because it's pretty much the SSH disk that the EC2 has attached physically. Obviously, the disk and capacity type will depend on the EC2 instance type because, again, these are physical disks, and the durability is at application level. So what I say here is that basically it is stateless, so it will not persist. But if you reboot it, you don't have an issue. But if you stop the instance and you start it again, the data will disappear, literally, because, again, ephemeral. The good thing is that they are super fast and obviously super cheap because they come by default with the instance type. But you are not supposed to put there any kind of data that you need to persist, okay? So from there, so that's one, right? The physical disk. Now, what if I don't want to use the physical disk that is attached to a specific type of instance of EC2 instance? So what you're going to do is attach your own disk. How you attach your own disk? Using Elastic Block Storage, or EBS for the short, and that's how you're going to see it mostly in this presentation and by AWS. So what EBS has a main differentiation between SSD and HDD. All right, okay, HDD, hard disk drives, which are pretty much the magnetic ones, and SSD, solid state drives. What the main definition that you have after that is general purpose, which is the recommended by default, is the disk that you're going to use for everything that needs the average speed, which is quite good with the GP3 and with GP2 as well. It will you can use this for a boot volume, for build desktop, low latency apps, and dev test environments. All right, production environments as well. You can use this for mostly everything. Now, why you are not going to go with provisioned IOPS or PIOPS? Because this pretty much is really expensive, and it's only used in the case that, bro, I have a critical business app that have a specific IOPS requirement, and I need to go way higher than what you will do with a general purpose SSD. All right. So this is used for critical business requirements and large databases. And now let's go for the magnetic. Cold HDD, you're going to use it whenever you're asked to save a backup or something that is mostly not accessed, and you want to have that in a disk, okay? Because there is a service for that. We are going to check that in 10 slides or so. Obviously, the magnetics cannot be a boot volume. Remember this, important. So again, this will be backups, and throughput optimized is whenever you have a streaming application, all right, and you need to save money in the disk on the EC2 instance because it's low cost, and for big data or data warehouses, all right. Really good throughput, obviously not as good as the throughput is really good, way better than the SSD even, but the IOPS is obviously lackluster. Complementary docs, EFS. EFS is Elastic File System. Yep, elastic file storage. Sorry, I have it here, which is pretty much an NFS on AWS, managed by AWS, that you can mount on several EC2 instances. You can mount on Kubernetes nodes. You can mount it wherever you want. The only thing is that obviously it supports the NFS protocols, and you need to use this using Linux. There is another service which is how is it called? There is one for Windows, which I don't recall the name now. I will remember in a bit. That's obviously if you have EC2 instances that are based on Windows and you need to mount a file system, you're going to go there. You're going to use that one. All right. How it works, I explained this on that you have a network interface, which is the mount target for every single availability zone. You can spin up more or less. So the connectivity to EFS is done pretty much locally on every availability zone. Now let's go for S3. S3 is super important service. One of the first service that AWS created back in the day. Things to remember about it. So again, this is object storage. It has eventually consistency model, which means that if you are modifying some, let's say that you created a file, right? And then you update that file. Whenever you read the file, as it is a global service, whenever you read the file, you might get the older version instead of the newer one. That's eventually consistent. Which obviously with time, you are going to get the proper version. All right. Now you get a few months ago, you are now able to do you can enforce the strong consistency, which means that you will not have this issue. Obviously, this is something that you need to enforce. That's it. It's not by default. There are several storage and durability classes. So the main ones are standard infrequent access, intelligent tiering, and one-zone infrequent access. Pretty much what it does. Standard is the default, the most expensive. So the pricing model for S3 is a little bit weird. A little bit weird in the sense that you need to keep into consideration pretty much two things. One is the amount of space used and the amount of requests. Okay, the amount of requests that you do against that storage. So standard has the highest price for the data at rest part, but has the lowest rates for whenever you are accessing that data. Okay. The infrequent access, in your hand, as the name consays in this, it is expecting you that you're not going to access those files that much. So they are going to charge you less for the storage, but charge you more for the request that you're making. Okay. Now, this obviously has a different availability, and you need to keep the data at minimum 30 days. All right. Now, the intelligent tiering, what it does, this is a service from AWS as well. Well, a lifecycle, let's call it. What AWS will do, it will take care of where the data should reside based on what you're doing with the data. So AWS takes care of it for you. So if you have data you're not accessing that frequently, it will move it automatically to IA. If not, it will move it back to standard, so on and so forth. One zone IA. One zone is one availability zone, which means that the availability goes way down, and it is one of the cheapest storage for the hot tier of data. Okay, we are going to see the cold tier of data in another slide. So again, we have the encryption data at rest. We saw that the encryption data in transit, HTTPS, and as well you have versioning. So you can keep a versioning of every single file. For the part two, let's go. You have the access control through bucket policies. We saw that multi-part upload. This is something that you do whenever you need to upload a really big file instead of uploading the entire big file. Amazon S3 will need you to partition it because you won't be able to go over a certain amount of megabytes. So whenever they are asking you in the exam, I need to upload 1 terabyte file into S3, you need to find the answer that says, hey, I will use a multi-part upload. All right. When you're using the AWS CLI, it will do the multi-part upload for you. If you're using an SDK, you need to take care of it. Well, maybe now, maybe you don't. But obviously, the API to access S3 is accessible through the internet. You have virtually unlimited capacity, so you will never have a space constraint. It's regional. Even though the Amazon S3 is a global service, as I said, the availability is regional, right? Except obviously for one zone that uses only one availability zone, and it is highly durable, which is 11 nines. I explained the costs, all right? But this is super important. You are going to pay for the data transfer outside of the region, all right? And they will not charge you whenever you're transferring to S3, whenever you're sending data to S3, and whenever you're transferring out of S3, but to the CDN or into the same region, okay? In the same AWS region. This is just a slide explaining how the URL is built, right? So you're going to have the bucket one with the bucket name. This is a general one, and AWS will take care of redirecting you to whatever region you want. Or if you want, you can specify the region here, and you're going to enforce the endpoint of the region that you selected, right? And this is for an object. That's good. Lifecycle. The lifecycle for this, I forgot to translate many slides. I was tired. So how the lifecycle works in S3? What you can define are stages for your data to go through different stretch strings. For example, when first arrive the file one, it will go to Amazon S3 standard. It will stay there for 30 days. After that, we are going to move it automatically via the lifecycle to Amazon S3 standard frequent access, and then we are going to move it to Amazon Glacier. But John, what is Glacier? We haven't heard about it. Oh, just a moment. We will discuss. After 1 year, let's delete that. All right. Just for you to know, Amazon Glacier is the cold storage from AWS that doesn't work for whenever you need to access the information on the fly. So it's an archiving solution. Whenever they are saying, hey, what's the best solution to archive something for a really long period of time? Or maybe I want to enable worm. Worm is write once, read many. I want to implement worm. What solution should I use? Okay, that's Amazon Glacier. All right. Let's go. I was explaining here. Amazon Glacier is a stretch for archiving or backups. It has vaults. In those vaults, you use the worm methodology. Again, write once, read many. The type of retrievals that you have are instant, which even though it's instant, the data is not there by default. So you need to go call the retrieval, hey, retrieve me this data, and then you're going to get the data. So obviously this cannot be the backend, the data backend for anything, for any live application. Then you have the flexible standard bulk, all right? You have the capabilities of encryption, as you had with S3. You have it can be part of the S3 object lifecycle policy, as we saw before. It's regional availability, and the durability is pretty much the same as S3, which is 11 nines. Now, CloudFormation. Oh, bro, how many slides do we have left? I'm anxious. Oh, we are around the corner. Oh, that's good. So, everyone's still alive? Let me take a glass of water, please. There you go. Any questions? Nothing? I've been talking nonstop for an hour. Like, you need to have some questions. Yeah, go ahead. Love you, mate. Thank you for asking. If the question is how do I do to speak for an hour without any stop, that will be one. Okay, that's a really good question, because it covers a lot of things. So the thing that you have with different providers like HostGate or GoDaddy and whatnot is that first and foremost you need to think about how that is deployed. For example, let me go and let me just write this down. So, for example, let's say that instead of HostGator, you have GoDaddy, whatever, right? And in GoDaddy, you have your Apache. You have your Apache server, and you're serving your things from this Apache server, and you are doing some PHP on it and whatnot, and you need to serve content. Okay. Whenever you're doing that, that is in GoDaddy, for example. If you translate this to AWS, it will, if you do it like that, it will end up being more expensive, because here you will need to have, just to replicate this, you will need to have a VPC, right? If you want to have some kind of availability, right, you're going to have, and security, you're going to have the subnets, right? And you're at least going to have 2 subnets for the public, 2 subnets for the private. You're going to create a load balancer in between for the backend. Oh, sorry. Love you. Thank you. That's good. There you go. Much better. Thank you, Mylan. Now you see, do you see the Excalibur part? That's good. So if you, I was explaining this and no one was seeing. All right, so in GoDaddy, let's say that you have in GoDaddy your Apache server running PHP, whatnot. If you want to translate into AWS, right? For this, you will require at least 2 subnets for the private, right? A load balancer, all right? A load balancer that will live in the public subnet. Let's say that you want to have your front end and back end all together in the same server. Then you will need to have an EC2 instance. If you want to have some kind of availability, you're not going to have an EC2 instance. You're going to have an auto scaling group, which is something that we didn't see yet, which basically allows AWS to handle the amount of EC2 instances that you need according to the traffic requirements and whatnot. So this will be like just to represent what you have in GoDaddy, and this will be way more costly than running in. Thank you very much. I've done it myself. This will be way more expensive than what you have in HostGator. So whenever you want to do that, it's, well, if you have a database, you will have an extra cost if you want to use RDS. RDS is super expensive. Obviously, on this EC2 instances, if it is an application that you don't care that much, you can create another EC2 instance really small, deploying a database. RDS is super costly because, again, as you're moving away from the shared responsibility model, right? Whenever the provider is taking more responsibility for you, which in the case of an RDS, it will be the PaaS part. Obviously, it will always cost you more, right? Because the provider will be responsible of more things than before. So you can deploy a database, a single database with only one node and whatnot here. But again, it will be more costly because it's something that you are doing for, you're not doing it at scale as GoDaddy does, right? Yeah. And for the mail server, you can use SNS, which is the Simple Notification Service from AWS. You have other options as well, but again, that's if it is if you are doing this. Now, let's say that, okay, we want to move away from HostGator because we don't trust HostGator, but we want something that is highly scalable and whatnot. This is obviously one option that will be super expensive. The other thing is, what you can do is, if it is a static page, right, you can just mount it on S3, right? You can mount it on S3. You can publish the static web page from S3 directly, right? You can use Lambda functions. This is something that we hit the slide of Lambda, which is serverless. Serverless is called the infrastructure as a service. Function as a service. It's on a specific tier where you can run the code. For example, pages like iCloud Guru works entirely on serverless. They don't have any kind of EC2 instances. All right. But indeed, if you have customers with VPS or dedicated servers, then yeah, it might make sense. All right. So yeah. Plus, you need to add the complexity of that. Whenever you're moving here, you need to have someone that actually understands this, right? Because one thing is handling a console like GoDaddy, say, yeah, create a server, push the files and whatnot. And the other thing is, all right, I need to manage all of this now in my company to host my web page, right? That was a really good question, Hugo. Thank you very much. So Glacier, CloudFormation, this is pretty much the Terraform, but specifically to AWS. So it's a declarative language. In Terraform, you use something called HCL, which is HashiCorp configuration language. What basically does is you write in a YAML file which resources you want to deploy. It uses templates and stacks to create the resources. So you have a template, and whenever you create a stack, the stack will create the resources in AWS. This is mostly not used. There are just a handful of companies because it's really vendor lock-in. You are not going to be able to work with any of the other clouds. Terraform, in the other hand, has by default the ability to work with Azure, GCP, and AWS all at the same time. Furthermore, you can work with pretty much anyone that has a provider, and if there is no provider, you can build your own. So yeah, it's not used, but you need to know that it exists. It's like Terraform, ARM templates, and I will say Pulumi, but for Pulumi you need to know Python, so it's a little bit different because you're not using a declarative language, you're using Python for it, or you can use Go or Java. Anyhow, that's it. So Lambda, what is? It's a compute service totally administered by AWS. So you don't know where it is running, how it is running, OS, you don't know anything. You just tell the Lambda, you just tell the Lambda service, hey, I want to run this Python application on this Python version, and that's it. And then you push the code, and AWS will manage it. All right, entirely. Now you're going to pay only for the compute time used, measured in milliseconds. So if your application runs and takes 3 seconds to execute, you're going to get billed by 3 seconds, which is super good whenever you have whenever you have a model or a start, or you're working a startup and you want your application to grow with your business, or your cost to grow with your business. This is the way to go. It is super inexpensive, super cheap. One of the best way of doing this, doing things. If you have, as a side note, if you have Kubernetes, you can use OpenWhisk or OpenFast, and you can deploy serverless, let's call it, or at least you are going to abstract or have the same model, but on top of Kubernetes. Just for you to know, it's a really nice thing. Axioms del domain 2, domain 2 axioms. Never an answer that says a single AC will be correct. Remember, you are going to get if you at some point in time take this architect associate exam, you're going to always be a good architect. All right, you need to put the hat of I'm a really good architect. I don't work for a shitty company. Single AC is never correct, never. All right, we as architects we cannot rely that everything will work. All right, use AWS administrative services, even though they are quite expensive. Whenever one of the options is we are going to deploy an RDS instead of an EC2 with a database, for example, then go for the RDS, because that will always be preferred, because we as AWS architects know that AWS handle things in a really good way. They do, not like Azure. Remember that fault tolerance and high availability are not the same. I explained this, and always remember that everything will fail at some point. So hence why the first part is super important. All right. Domain 3, let's go for performance. We are just 10 slides away, or 11. Pretty good in the time. Highly, oh my gosh, I forgot to translate mostly all of this presentation. All right, high performant design, high performant architectures. What we will need to do is identify elastic and scalable compute solutions, scalable and highly performant storage solutions, highly performant network solutions, and highly performant database solution. Let's go for that. So EBS volumes, once again, right? Always remember this. I put here the table. I will share this with you so you can have it. They will not ask you in detail if you are taking the exam, or if you plan on taking the exam. They will not ask you what's the max volume size for the SC1. No, they will not ask you that. All right, you need to remember that for all except the standard is 16 terabytes. They will not ask you how many IOPS. What you need to know is, bro, when they are talking about massive IOPS, over 16K, all right, that's provisioned IOPS, all right. They will not tell you like 16,500. They will tell you like 30K, 60K, 100K IOPS. They will go way above. Like you don't care about this limit. Why? Because first and foremost, this is usually always changing, all right. For example, 2 years back we had CP2. Now we have CP3. CP3 changes a bit, and the IOPS went up for both of them. The throughput as well. So they are going with way too high. Whenever they want you to pick one or the other, you're going to notice, because they are going to make a lot. They are going to push you like, we need that, we need that. We have a massive application that works with massive amount of IOPS, like 1 million IOPS, whatever. And then you need to pick, right? Mostly, and they will not differentiate you between CP2 and CP3. They are going to call it CP for general purpose and provisioned IOPS, all right? But always remember that if you want to go cheap, as you can see here, the standard throughput is way higher than the general purpose, except for the CP3, that is the newer version. But this is still cheaper than the CP3. All right, these are the magnetics one. Remember, this is the solid state. Databases. We have 3 types of databases. So we have the RDS, or Relational Database Service, Amazon DynamoDB, Amazon Redshift. We have many more, yeah. So we have Neptune, which is the graph database. We are not talking about in-memory database yet. We are going to talk a little bit, but we have many, many more, right? We have OpenSearch, which is the fork of Elasticsearch, since AWS had an issue with Elasticsearch modifying the license type, because AWS was using Elasticsearch and was not helping the community. Lovely story. So let's go for the databases here. RDS goes for the ACID model. Remember this is RDS, and this is pretty much SQL, not RDS alone, right? So whenever you are using RDS has many engines, PostgreSQL, MySQL, Oracle, Microsoft SQL Server, and whatnot. And all of those databases, they follow the same model, which is the ACID model, right? The ACID model is because of the atomicity, consistency, isolation, and durability, which is pretty much what makes a SQL database a SQL database. But when you should use this? Whenever you have complex transactions or queries, whenever you have a read-write rate between medium and high, not massive, when you do not require more than a worker per shard. Okay, this is Redshift, which is a data warehouse. You look up for high durability, right? Which is part of the ACID model. When not to use this, when you have massive read writes, right? Which is 150K ops per second, something that for you to keep in mind. Most probably they will not tell you this, they will tell you massive. When sharding is required, when you require personalizing the RDBMS, and RDS, as it is a pass, it will not allow you to go into the EC2 instance. So if you have any kind of a storage procedure or anything like that, or anything running as a service, you won't be able to do that. But most probably in the associate, they will not ask you that. And for simple queries and requests like get put, because for that you can use plenty of other services. Now, this is how the read replicas work. Remember that the read replicas are only supported by MySQL, MariaDB, PostgreSQL, and Aurora. DynamoDB, on the other hand, is the NoSQL database. You have seen NoSQL database most probably with Mongo. They follow the same path, which is not relational. It's the base model. Base stands for basically available, soft state, and eventually consistent, instead of ACID, which is the SQL databases. In DynamoDB, which remember is an AWS service, you have 2 ways of accessing the compute resources, or assigning the compute resources. One is the provisioning throughput, and the other one is on demand. Let's go for the on demand first. On demand is DynamoDB will take care of having the proper resources for your application to work. All right. In your hand, provisioning throughput, you will need to assign that. You need to assign it manually. Like you're going to have, it's like assigning how many CPUs you're going to have, all right? How many CPUs and how much RAM. Now, they will not ask you for this, but you might need to, maybe if you remember, it's okay. The read capacity unit, it's always like this for a 4 KB size item. You don't need to remember this, but you need to remember the read capacity unit, all right? Whenever you're assigning how many capacity units your DynamoDB needs, it's 1 read for externally consistent per second, or 2 reads for eventually consistent. So if the question is, bro, we have 12 reads per second, eventually consistent. Okay, you need to divide that by 2, and that's the read capacity unit. You have 6 read capacity unit, and the write capacity unit is for a 1K size item. It's one read per second. That's correct. Yeah, 1 write per second. Sorry, I need to change this and pretty much translate part of the presentation. CloudFront. If you do not know, CloudFront is the CDN from AWS. CDN stands for Content Delivery Network. The content can be either static or dynamic, so you can point your CDN to S3 for static content, or for example, an ELB where you have, oh my gosh, servidores. ELB in the origin that you have the servers behind it, so it will be dynamic as well. Protects the private content, and the security on the CDN can be improved by using AWS Shield Standard, which is the default. This comes enabled by default in every single account, not costing you money. That helps you prevent, for example, a DDoS, or advanced, where you can set up certain specific rules if you want to, or obviously you can implement AWS WAF. WAF stands for Web Application Firewall, not in AWS, but in IT by default. And that allows you obviously to have another layer of security in front of your application, for example, for SQL injection and whatnot. Right. This is the cache with CloudFront. For anyone that doesn't know how a cache works, but pretty much a user requests something, it will go first to the CloudFront edge locations. The edge locations are in AWS are specific locations that you cannot deploy a service specifically, but certain services leverages those locations for you. There are plenty. So if the data is not there, it will go to the origin, it will grab the data, it will put it in the cache, and then from the cache, it will be served to the user. If a new user makes another request to the same thing, it will go to the cache, it will find that it is cached, and it will return without going to the origin again. Thus, saving you money, helping you with the performance of your application. So it's CDN is usually a good idea whenever they are mentioning it. The other way of doing caching in AWS is using Elastic Cache. Elastic Cache is the service from AWS that allows you to deploy any of two technologies for in-memory databases, which are Redis and Memcached. All right. So you can put an Elastic Cache in between. It is really easy to integrate with DynamoDB or RDS, or even with MongoDB, but with DynamoDB and RDS, it's straight out of the box. So you can put it in between. Thus, you don't need a bigger DynamoDB or RDS instance to handle the same workload, because you're going to serve that from the Elastic Cache. So what are the difference between Memcache and Redis for you to know? Obviously, Redis allows data structure support, persistent atomic operations, PubSub messaging. Yeah, bro, servidores, my friend. Read replicas, failover, cluster mode, share clusters. In Memcache, in the other hand, you have the good things is that you have multi-threading, low maintenance, and the most important, easily horizontally scalable through auto discovery. Okay, so good things. Memcache, super simple to manage, easily scalable horizontally. Redis, a little bit harder to manage. But you have PubSub messaging and read replicas failover, which is super important, and the cluster mode. Let's go for the load balancers. Right now we have 4 types of load balancers: classic load balancers that work on layer 4 and 7, network load balancer that works on layer 3, application load balancer that works on level 7, and gateway load balancer that is something that you're not going to use because it's a specific use case, and that's why they create this service. And it works on layer 4 as well. So the 7 layers of the OC model, if you do not know them, it's physical, data link, network, transport, session, presentation, no, I don't call the other one, application, yeah. So pretty much classic load balancer and network load balancer, they work on layer 4. Classic works on layer 7 as well, but layer 4 is just sockets, right? IP and ports. That's what you can handle with the network load balancer and that part of the classic load balancer. When you're talking about layer 7, you can parse a URL and URI and be able to say, all right, whenever you are hitting /users or /sign up, you can go to these endpoints instead of these other ones, to this backend instead of the other one, or listeners actually. ELD complementary, there you go. So we talk a little bit about this. So there is a scale up, scale down versus scale out, scale in. Scale up, scale down is whenever you're modifying the resource specifications or the resource assigned to for example, an instance. So if you have an EC2 instance that has 2 CPUs and 4 gigs of RAM and you move to 416, you're scaling up. And whenever you are deploying the same instance over and over again, right, you're scaling horizontally, which is a scale out. This is something that I wanted to mention here. Now that we talk about auto scaling, the auto scaling group, an auto scaling group allows, as I explained when we talk, yes, exactly. There you go. What the auto scaling group does, as I explained when we were talking about the HostGator GoDaddy thingy, basically it starts or terminates instances, which means that according to the traffic that it is receiving, or you can schedule as well, you can schedule a time for example, okay, at 9 a.m. scale up to 10, and after 6 p.m. scale to 2 or 0 even. It will or according to the traffic, it will start or terminate instances, which means that it will not stop. This is super important. An auto scaling group will never stop an instance. It will terminate it, which means it will delete them. All right, because there are some tricky questions that say that now the scaling group will actually stop it, and you're not going to be able to. It will automatically register new instances with load balancers. So whenever you're configuring a load balancer, instead of configuring the EC2 instance directly to the load balancer, you're going to configure the auto scaling group. And obviously, it can launch EC2 instances across several availability zones. So this will keep your application highly available at least. Axioms of the domain tree. If the data is structured, Amazon S3 is generally the go-to option, because with Amazon S3, you are basically, as it is object storage, you can build your own data lake. Always use caching strategically to improve the performance. So if any questions that is being asked, they tell you we need to improve the performance, let's scale up the RDS instance. Remember, scale up, increasing the CPU and RAM. Or put caching in between. Put caching in between is the best option, because you're not only improving the performance, but you are decoupling your application, which is something that we discussed in the domain one. Know when and why use auto scaling. Okay, this is super important regarding, for example, whenever you want to have something that scales at a certain point in time or according to the usage, then auto scaling is the way to go. Choose instance type or database type that makes the most sense regarding the application and performance. This is go for SQL databases whenever you need something that is reliable and fast, and you need this ACID model, right? Again, if you're working with credit cards, if you're working with even stock, if you at some point in time they say you have a warehouse application that keeps track of the stock, it's super important that you don't have eventual consistency, because whenever someone buys something, that item is not it shouldn't be virtually available anymore, because you cannot oversell your own items, right? And if you do that, you're a shitty vendor. So you're going to go for an ACID model. Now, if you need to have flexibility, scalability, like, bro, I have blog posts. All right, you're going to go with a base, with a NoSQL. Why? Well, because it doesn't matter if the picture that you upload from your docs in Instagram is not immediately uploaded to the internet. All right, it can take up to a few seconds for everyone else to see, and that's okay. It's not urgent. It's not like anyone is going to die. Let's go for the main 4. Let's go for cost. I have only 4 or 5 slides left, and that's it. I promise you. Cost-effective storage, database, and network. All right. These are just a few key points for you to remember. EC2 pricing on Amazon EC2 pricing. Time the server is on they are going to charge you for the time the server is on. Okay. So if you have the server up, even if you're not using it, they will charge you for that. If you shut it down, they will not charge you anymore for that, even if you have it assigned, let's call it. Sorry, I received a message. Now, one thing though, that they are not going to charge you for the EC2, but remember the AWS, the block storage that you attach to the EC2 instances whenever you don't want you want the data to put the data in somewhere that is persistent. Well, the AWS volume, they are going to keep on charging you on that, right? EC2 instance configuration, obviously, if you are using a smaller instance, they will charge you less. If you are using one that has a GPU, they will charge you more. EC2 instance reservation type, there are 3 types of, let's call it not reservation, but 3 types of getting an EC2 instance. On demand, which is when you don't reserve anything, just go click on create and that's it. The spot, which is a bidding system. I explained this a little bit further in the next slides. And reserved, I explained this a little further in the next slides as well, which is whenever you want to reserve an instance because you can commit to using that instance. So AWS will charge you less for that. Obviously, the number of instances, if it is fixed or scalable. So auto-scaling group is super important, remembering according to the cost. So you need to do this dynamically. Load balancing, that helps obviously on having the auto-scaling group in place. And the operating system and software third-party appliances. So they will charge you if you don't have a license. You can do the bring your own license or BYOL for example, Microsoft. But if not, you can obviously pay AWS for that license. But again, you can deploy as well, for example, a FortiGate appliance, and FortiGate will charge you for having that deployed in your AWS account, like if you were paying the license. Obviously, as you are paying the license, you have support as well, which is super nice. But nevertheless, you need to keep that into consideration. Reservation versus spot. There are service instances for you to know. They gave you a significant discount up to 75% versus on demand. You have 3 types: standard, convertible, and scheduled. Standard, you can change the instance type. Convertible, you can subdivide it and you can change the instance type. And the scheduled reserved instances is used during certain amount of time. Oh my gosh, tipos de instancias reservadas. Spot instances in your hand. This is reserved instances types. I forgot to translate most of it. So spot instances is you can save up to 45, but the difference here is that the spot instance is a bidding system, which means that you say to AWS how much you are going to pay for the instance. Now, if anyone else pays more than you, AWS will shut down your EC2 instance that is in the spot type, and the person that paid more than you will start working on it. So you will need to bid again, or you can actually configure this to whenever someone is bidding higher than you just bid higher. But again, this means that whatever you deploy here cannot be an application that you need to have 24/7, or that you need a long process, or you have a long process that runs, for example, 24 hours, because maybe in 24 hours your EC2 will go down. So what could you do with this type of instances? Whenever you have an application that you need to process, but you don't care how much time it will take, and whenever it's going down, the progress is saved, something like that, all right? And I think that's batch. Serverless architectures, all right? We spoke a little bit about this, but they are charging you literally nothing. So any of the serverless alternatives like Lambda, S3, DynamoDB, API Gateway, which basically helps and gives you an API endpoint, and CDN, they are always good options for you to improve the costs, all right? Remember Elastic Cache as well, that helps you not to increase the RDS. That will be really expensive, for example. So caching is always good to know. So last slide, domain for axioms. If you know that it will be used for a really long time and you can commit yourself, go for reserved instances. Reserved instances, another highlight here. Reserved instances, you can reserve this for a year, 2 years, or 3 years. And you can pay all upfront, partial upfront, or no upfront. The most saving is 3 years, pay all upfront, right? Exactly. Yeah, Amazon Lambda is pretty much Google Cloud Functions or Azure Functions as well. Yep, we can see it if anyone is going to stay, I will stay a few more because this is the last slide. So all the time a CPU is not being used, it will be charged. We explained this. Use the most cost-effective service and storage class. We discussed this on a stream. Remember that you have to, this is a balancing act between the cost of the storage versus the cost of the request. Whenever someone is saying this is not frequently accessed, okay, infrequent access is by default. It is not frequently accessed, but I also need, I don't need that much availability. Okay, then it's once on infrequent access, right? I need, this is going to be archived. Okay, Glacier, right? Think about that. Remind the most cost-effective EC2 price model for each workload. For example, ephemeral workloads can be recalled. Go for a spot if EC2 is needed. Furthermore, you can go with ephemeral volume, something that we saw at the beginning, saying, all right, we can use this as well because it's ephemeral workload. All right, that's it. Okay, so we finished with this. That was a sprint. All right. Questions? Anything? Or let's begin a little bit with the hands-on.
Okay, can you hear me?
Yes, of course. Oh my gosh, another voice. I thought I was crazy.
Oh, wow. That's right. Okay, I have a question related to the big difference, or not so accurate difference, but a big difference between EC2 and ECS.
No, those are two different things. Totally different. So first and foremost,
there are different services.
Those are totally different services. Yeah, I will explain that. I can explain that in a bit. So ECS, first and foremost, is a platform as a service. Remember that we had this. Let me put the shared responsibility model. We have this definition here: infrastructure as a service, platform as a service, and software as a service. ECS is Elastic Container Service, okay, which is pretty much what Azure Web Apps is, right? So what you do when you do this, so you can actually compare more like ECS with EKS than ECS with EC2. You can create a cluster here, right? Well, I will instead of creating everything, I will just put it here. So what you do with an ECS is, whoops, there you go down, there you go, lovely. So let's go for the ECS and let's go for the EC2. So an EC2 is something that you have access to it, right? And on top of that EC2, for example, you can say, all right, I'm going to run an EC2 that is Linux, right? And here I will install an HA proxy, right? Or you can install Apache or Tomcat or whatever, okay? On ECS, when you deploy ECS will deploy a cluster that first and foremost, the cluster can be of two types. One using EC2, or the other one that is going to use, or you can use an ECS serverless. So if you go here and you can go for AWS Fargate, which is serverless. Okay, so you don't even have an EC2, right? Or you can pick up the EC2 instances or external instances using ECS Anywhere, which is something that you need to install in your on-prem if you want to use this. Okay, the current method for deploying this, because it's less expensive, is using Fargate. So you are in the Fargate, you're not going to even have EC2 instances. You're going to have a service where you say, okay, in this ECS, I want to deploy an HA proxy, which is a Docker image, right? And basically what you need to define the task and the service. Those are certain things that you need to define on ECS, and ECS will take care of you running that HA proxy there, okay? But it might or might not use EC2 instances even.
Okay, that's perfect. Another question related that to ECS. It's similar to EKS, but the difference is one is for containers, and the another is for Kubernetes implementation.
Well, ECS is a proprietary. First, it's a proprietary solution from AWS. Okay, so you're not going to have ECS on GCP. All right, in order for you to have ECS on GCP, you need to go with the ECS Anywhere that we saw here, and you will need to install it, which will be crazy as hell. It is quite similar to Kubernetes, because at the end of the day, even though Kubernetes, the minor unit in a Kubernetes cluster is a pod. So whenever you have a Kubernetes cluster, it doesn't matter if it is EKS, AKS, or GKE, depending on the cloud vendor that you have. Kubernetes will deploy EC2 instances for you when you're using EKS, for example. And on top of this, you're going to have pods, right? And within these pods, in Kubernetes, which is the minimal unit that you have, you're going to have containers, actually.
Containers into the pods.
Yep, that's the definition of a pod. Yep. So every single pod has many containers within it. The definition of the containers in the pod is that one is the main one. You always have at least one. You cannot have less than one. Okay. So every pod that you have, it will have at least one container. Then you have a main container, which should be your application. For example, let's say that you're running a Tomcat or an Apache or Node. Yeah, and then you can deploy many containers within the same pod that are sidecars. These are called sidecars, which basically assist the main but are not related to your main application. For example, let's say that you want to have another application running in the same pod that gathers the log of your application and sends that to a log, assist log, right? Then you will not add that logic in your application. You will add that logic in a sidecar container that will be in the same pod. So it will grab. Why are you doing this? Because the pod has the resource, okay, has the same resource, and you can access, for example, between this container and this container. So if you want to access from this container to this container, oh my gosh, there you go. You're going to do localhost because it's within the same pod, right? So the context is the same for the pods, for the containers living within the pod. So this is how Kubernetes work. As well, you have another container that within the pod, right? I need to expand this, which is the init container. So let's say that you have a task that needs to be done before this container starts within this pod. Let me expand this. There you go. So for example, modifying, doing a change mod on the file system, right? Or creating a user, or adding this pod to a service mesh or whatever. You can have an init container, which is an ephemeral container that will run that task. And then once it completes, it will disappear, right? Leaving only your main container and the sidecar containers that you created within it. On ECS, you can do pretty much the same thing in a different way. But here, indeed, you're using container images and deploying that. But you can have sidecar containers of some sort. But again, this is proprietary. Meanwhile, Kubernetes is widely adopted. You can use Kubernetes on AKS, in EKS in AWS, AKS on Azure or GKE with minor modifications, like literally minor, if any.
Okay, that sounds good. Thank you.
My pleasure, my friend. Anyone else that has any questions that I love to answer? So far, so good. So aside from Pablo, everyone is pretty much alive still. Yes, that's good.
Yeah.
That's good. Okay, so let's finish. Well, at least let's finish with the VPC that we created, right? We created one. So let's go for the first slides, right? Remember, public subnet, internet gateway, private subnet, NAT gateway, route tables, whatnot, security groups, blah blah blah. Where do I have that? Here. So this is what we are going to do quickly. And let's see up to which point in time you are still alive with me. So we have the workshop VPC. Now, if I go to subnets, right? What I need to remember is that the CIDR that I used was the 10.0.0/24. So any subnet that I create inside this CIDR block needs to be smaller, obviously. So let's create two publics. Public 01, 10.0.0/26. Yep. Christ's sake. 26. It will be 64. That's good. I will add another subnet, right? I will add a public 02 now. I will put this CIDR block, but instead of 0, it will be 64. If you do not know about how to do subnetting, just let me know, and we can have a call and I can explain this. It is super straightforward. Once you see things as in the binary way. Private 02. And this will be 132, right? Anyone that's good at math can correct me. So what I'm doing here, I'm just creating 4 subnets. I'm putting a name, all right? But the name doesn't make it public, okay? It doesn't. What will make this subnet public or not, it will be the route table, okay? So I'm creating 4 subnets that should be within the main CIDR block of my VPC. I just split this VPC into 4 blocks of 64 IPs. So I added 26. Okay. And this is, I added this wrongly. 128. Wait. 00. 00. That's good. 0. Sorry, I had this in the wrong section. I have really just a few of IPs. That will have been for a /60 for a /16. For Christ's sake, 0. And there you go. Oops. It's correct, right? Nope. 192, sorry. So all of these are within the 10.0.0.0/24. And again, I don't have, I created this like by default, so I didn't split. You can split whenever you're creating a subnet, so you can specify which availability zone is. Everyone knows what an availability zone and narration is by any chance? Or anyone that do not know? Okay, that's good. I presume that everyone knows. So let's convert this into public and private, right? We have a route table, which is the default route table. We are going to use this route table as the private route table. So let's put here the private route table. So whatever subnet that we create, as this is the main yes here, if we create a subnet, it will not automatically be accessible from the internet, which means it will end up being more secure. Now, I said that we need 2 route tables. We need one for the private and one for the public. So let's create the public RT. All right, let's select a VPC, which will be the workshop VPC. And now the difference between public and private, if you recall, you can filter all of these things by just picking here the VPC. So the main thing that we needed, right, is the public to have a route, right? I said that this is a default route for the VPC. Remember, this will be there by default in both of them. The public will need to have a 0.0.0/0 to an internet gateway, and the private will need to have a 0.0.0/0 to an NAT gateway. Now, in order for me to be able to do that, the first thing that I need is an internet gateway and a NAT gateway. So let's go for the internet gateway. Let's create quickly an internet gateway in here, workshop HE. Okay, I will create it. Now, it is created, and if you see here, this is the touch. So the first thing that we need to do is attach to a VPC. The VPC that we are going to attach this is the workshop VPC, the only one that doesn't have one. So that's why it's only one there. I'm attaching the internet gateway. That's it, right? Now I have the VPC with an internet gateway attached. Now, what I need to do first is create a route table, working route table, go for the public route table, go for the routes, edit the routes, and add one route that is this 0.0.0/0 to an internet gateway. Oops, not local, internet gateway, I said. Okay, it will only one appear because I have only one attached. I save the changes, that's it. Now I have this public route table with the route to the internet gateway. Now, this route table was not associated with anything because I created from scratch. What I need to do here is do the subnet association. What I need to go here is click on edit subnet association. I will pick the public ones, save the association, right? And once I've done that, now these 2 subnets that are associated with this are the public ones, right? Which now it falls in line with the name of the public. Now I'm missing something still. I need to make the privates private, although they are already, but I need them to have access to the internet. As I said, I cannot forward it to the internet gateway. I need to go with a NAT gateway instead. So I need to deploy a NAT gateway. And for this, I will use one of the public subnets that we have created, because the NAT gateway will be in charge of NATing. Ergo, it needs to have access to the internet, and the only subnet that has access to the internet are the public ones. And as I can see, these are the ones. That's good. Okay, connectivity type, you can pick obviously if it will be public, or if you want to have a NAT for the private endpoint privately, that will be crazy. I'm going to allocate an elastic IP. Elastic IP is pretty much a public IP that AWS provides you. It is free if it is attached. If it is not attached, they will charge you a small fee. So remember to have your elastic IP attached to something. Okay, I'm creating the NAT gateway. Now the state is pending. I need to wait a bit. Okay. So let's see if I can do this already on the private route table. So now what I need to do in the private route table, going to the routes, I will edit the routes, and I will add this, the 000/0 to the NAT gateway. I have it already. That's good. Okay. Now I have a fully functional subnet. John, but how can we check if this works? All right, let's deploy 2 small servers. So make sure he doesn't kill me. Aside from my EKS that is right here. So I will just launch 2 instances. All right, I will launch server 1. Let's make it an Amazon Linux. All right, and keeper name. All right, you can pick one of these that you have created previously, or you can create a new keeper. You're going to use an SSH keeper to connect here. Workshop workshop 1. Let's call it. Okay, important thing, I need to change the network settings, right? I need to deploy this on my new VPC, which will be the workshop VPC, and I will deploy this in the public. I will enable the auto-assign public IP. I will create a security group, right? That will be workshop SG public, right? And I will allow from everywhere, right? The 000 is everywhere or anywhere to the port 22, so I can connect to it. Okay, that's it. I save the pen. That's good. Okay, and now what I'm going to do is do the same, but I will deploy. I will deploy a server 2 on the private. Amazon Linux, same thing, same thing, same thing. Here I will pick the one that I created just now. I will modify the network settings by any time now. There you go. Workshop VPC. Instead of public, I will pick one of the privates. All right. I will assign a public IP so you can see what it happens. All right. What happens. So it will have a public IP as the other one, but I'm deploying this on the private. Right. I will launch the instance. Okay. Now both instances are going up. So far, so good. Now, what I'm going to do is I will just stop sharing this part. I will share my entire screen as it will be simpler for me. Unless I want to switch like a madman. Oh, there you go. This is something that you need to do whenever you want to connect to a Linux instance with a PEM file. You need to change the permissions on the file. You can use 600 if you want to as well. And here the default user will be EC2 user, right? And here I will put the IP, which I'm not sure if it is already up. Yep, it is. Okay, now I'm within this server, right? I'm within this server 1 that I created. I can check that if I go to the details of the private IP is 10.10.10.0080, 10.0080. So far, so good. Yes, everyone there? That's good. Now for reals, any questions so far? Nope. All good. That's good. Now, if I do this, but I go.
Sorry.
Yes, my friend. Tell
Sorry,
me.
a little question. Here in the command line, you can use, for example, a local a local Terraform process or command?
When you refer to here I'm not sure where you.
Oh, yeah. I see that is the remote terminal, really?
No, this one. So the one that you are seeing here, right, is me on Windows using WSL2. Okay, so
Yes.
this is an Ubuntu running actually it's running as a Docker container in my computer.
Yeah.
Okay.
Yeah.
And here I have Terraform because I work with Terraform, so I have Terraform here.
Oh, okay.
But that's because I have it. That's a habit. I have it installed. Okay. So again, to the server one that is in the public, right? I can connect to it, right? This is the instance on AWS, right? Now, if I try to do the same, which the configuration is the same, the only thing that changed with the other server is that I deploy it in the private, ergo it has a different route. I cannot connect to it. Furthermore, if I do an netcat, right, to the 41, 231, 21, 422, and let me do a timeout at the beginning, right? I don't have any response whatsoever. Now, if I do the same and see set v to 422, obviously it succeeded, right? So this is the only difference that both server has is that, again, I cannot access the one in the private because I don't have an internet gateway, and the internet gateway is the one that matches the public IP. I'm going through another gateway. Now, if I connect to the one that I can connect, right? Actually, what I will do is I will do an SCP dashi to this was okay. Let's go just there you go. Hold a second. This was workshop one. Bam. True. I will do the workshop .pam. Copy this, change mode, workshop PAM, say workshop PAM, EC2 user. I don't need to add the EC2 user because I'm in the EC2, I'm the EC2 user here, and I will just go and grab the private IP of this. And as you can see now, I'm connected to the private instance, but in order for me to connect to a private instance, I need to went through a public one. Okay. Now, okay, I will spend the next 2 minutes to show you the difference between security groups and network access control list. So we have the workshop SG public, remember? And remember that we can only allow, right? So I can only allow here whenever I do the edit inbound rules and I add a rule, I don't have here the chance to put allow or deny, right? I can just allow. As I'm allowing the port 22, anything else is not allowed. So for example, if I go to the previous one, right, and I do a ping, I don't have a response because I don't have ICMP, right? If I go, oops, if I go here and say, all right, I want all ICMP, right? I will put anywhere, right? I will save the rules. And this was not in the right security group. This is your security group. So I can show you that by doing this. Okay, the ping response, right? I will leave it running here. Now I will go to the inbound rules. And I will go here, and this was the ICMP. I will delete it. I will save the rules. Okay, rules are saved. Anytime now. Did I leave it the proper one? Yep. There you go. Because the channel was established. Now it doesn't respond me anymore. I just cancel and rerun it. Okay. Now, as I said, we have that, and this is something that you can check on the EC2 level. If we go to VPC, in VPC we have the security groups as well, but we have the network access control list. All right, and we will have one default network access control list for our workshop VPC. Okay, and here we have inbound and outbound as we had in the security group, right? But here you have the allow deny, right? Now, important things. I will just go and re-enable the ping on the security group. Which was named public SG. Right, I don't see that one, right? Inbound rules, add rule, ICMP, source, say rules. Okay, now the ping is working, right? But if I go here and I edit the inbound rules, this is the security group, sorry. Now I'm the network access control list, okay? And for example, I can remove this actually because the default will be deny. If I save the changes, you see that it stopped responding. This is network level, not security group level. Okay. Now, furthermore, I will add the rule, right? Rule number 100, as we had before, custom CCP, all traffic, right? Source, everything, allow. I will add again. It came back, right? But if I go to the outbound rules and I do the same, this is important. I'm in the outbound rules now. So the rules from this server, the server that I'm pinging to my computer, right? If I save that, you see, it stopped responding again. Because remember that the network access control list is a stateless, not a stateful. Okay. In the other hand, if we go to the security groups, for Christ's sake, in the outbound, let me just modify this back again. I will add a rule again. I will add all traffic anywhere IPv4. Save. Sorry. What was I doing? This is security group. Oh, sorry. That was control list. Add rule. Christ's sake. Oh, I'm again in the. Why? I'm clicked. Oh, Christ's sake. Why is that happening to me? Am I the right one? Yes. All traffic. There you go. Now that I save this, there you go. All right, it is pinging. Okay, network access control list default. Now I will go to the outbound rules of the security group. Okay, and this will show you the statefulness. And here I have remember that I can only explicitly allow, right? This is the outbound. Okay, so if I delete this should stop responding, right? It doesn't, because the return traffic is always allowed in the security group. That's why it is stateful. Okay, what this prevents is that if I go to the server, okay, I'm in the server now, and I try to do a ping to the 888, which is, so I'm in the server and I'm initiating a connection. Okay, I'm not returning any traffic. I'm initiating a connection. It is not allowing me because the connection is established from the EC2 instance. It's not return traffic. Okay. So if I add this again, you see that it starts responding now. Okay. That's the difference between a stateful and stateless. Stateful will always keep the return traffic alive. Stateless will not. All right, guys, let's finish it for today because I'm really tired. Thank you for staying with me. That long, this long. I hope that you enjoyed it.
Yay,
Oh, you want?
Yeah, really, so much.
we are alive.
That's good. That's good. Only 6
Yeah, we
out of
are.
20. So the rest, I presume that everyone else committed suicide. Okay.
So you achieved your goal.
I achieved my goal. Obviously, less confidence for me. All right. I don't need to deal with it. If I'm the only one in IT alive, I'm the only one being paid, bro. So yeah.
Okay, so that's the strategy. Okay.
Mhm.
I have a question.
Shoot, my friend.
I have a question. This unit will be in the exam?
How to do this?
No. This unit, this class will be in the exam, in the next exam?
Yes.
Oh, damn it.
In what exam?
Okay, I will
What
be-
exam? I have no clue what you're talking about. Ah, you lost.
The
No,
major,
there is
the
nothing.
major Q1. We are adding this to the recruiting process.
You're kidding me. For real?
No, of course I'm not doing that. Don't worry.
Okay.
Okay. But we are recording this, so be aware of what you're saying, Jonathan.
That's good. That's good. You have evidence now. All right.
Yes.
Well, I try to do my best. I try to keep it as light as possible. But as I always say in every single workshop, if you have any technical doubt, if there is anything I can do to help you out, all right. If you don't know where to run, just ping me. All right. I'm glad to help you guys.
Okay, thank you. I will be wait the video. When I have a little time to watch so deeper, I write the questions and I ping you, Jonathan.
Feel free. All right. That's why
Thank
I'm
you.
here. My pleasure. All right. So thank you, Pablo. Thank you, Chris. Thank you, Lucas. And thank you, Danny.
Thank you very much for your time. Have a nice
Wait,
day.
whoa,
Take care.
whoa. What about me?
No,
I've been here the whole time. I
Most
just
probably
learned a lot
you were
about.
doing something else. You were doing
No,
something else.
You
bro.
don't know that. You
You
don't
were-
know.
yeah, I know.
I'm a
Who
cloud
said that I
expert
haven't
now.
You're a cloud. Oh my gosh, that's great because I need some help. Can you lend me
Okay,
a hand?
I'll help you out with the deployment something.
That's good. Thank you.
Yay!
That will be much appreciated. All right.
Great. Okay, everyone.
Okay,
Let's
sister.
keep in touch.
All right. Love you all, guys. Cheers.
Bye-bye.
Okay, cheers. Bye bye.